I am here to talk about, title, better continuous integration with test acceleration. I work for Electric Cloud, and we're sponsors of the event as well with IT Rev. And last year we got a lot of feedback from DUS that there wasn't enough of a focus on testing, test automation, test acceleration, testing in general, how it plays into kind of the DevOps landscape. So this year I think you guys have probably seen a few more talks about testing than we did last year. So I'm going to be talking mostly around CI tests, but a lot of the stuff we talk about can be extended out to other tests. Introducing myself a little bit, I started Electric Cloud back in 2006 as a software developer on our automation product, and over 5.5 years or so on the dev team, and then eventually I moved over to the solutions engineering side, so kind of the pre-sales engineering. As I've been doing that for the last 2.5 years, I've had the opportunity to meet a lot of people, a lot of companies. Maybe some of you, I don't know, don't see any familiar faces, but as I've been working out there in the field using both our automation and acceleration tools, I've had a chance to kind of see for myself and see some trends in the industry and see kind of what are best practices around testing, how we can be better about testing, why testing is important, and so on. So a few things I'm going to cover today. Why testing is so important. Problems with long-running test suites. Obviously, we're talking about acceleration. A step-by-step approach to speeding up tests, depending on the maturity of your organization. Some places don't even have tests, and a lot of places have a significant amount of automation, but there's always room to improve. I'll do a quick overview of one of our products, Electric Accelerator, and talk about a couple of successful use cases that I've had out in the field, working with different customers of ours. I'll do a quick 10 minute or so live demonstration, and then we can open it up for questions and answers. I'd love to hear your guys' thoughts. I know that testing is very different at different organizations across kind of the software world. And if you have any thoughts, questions, feel free to fire. So I'll start, as all good talks start, with the Dilbert comic, and I'll give you 30 seconds to read it. So my number one observation when it comes to the realm of automation, DevOps, continuous delivery, everything that we're here to talk about, is that this is a real thing, right? This is the size of DevOps enterprise over the last couple of years is kind of testament to that. We have to focus on treating automation and our software delivery process as a first-class citizen. I think that over the years it's oftentimes been kind of an add-on, an afterthought. Oh yeah, we should automate, or we should accelerate, or we should kind of spend time focusing on that. Everyone here in this room, the fact that you're here means that you already recognize that, and I think that's great. I think that we still have a long way to go, but we have to treat it as a first-class citizen. We have to invest in it accordingly, and I think that a lot of the companies that are successful in what's a pretty competitive landscape, depending on where you sit, spend a lot of time figuring this stuff out. So they are pretty high stakes, right? Depending on what software industry you're in, or what industry you're in, but software is everywhere. Software is growing, and software, obviously is kind of the past, present, and certainly the future. You've heard probably a lot about automotive recalls in the past, right? Ford recalled over 400,000 cars because of a software bug. Healthcare.gov, I probably don't even need to say anything more. Healthcare.gov. I read this one actually yesterday when I was looking for kind of high-profile things. To keep a Boeing Dreamliner flying, you have to reboot it every 248 days. That was a bug that made it out into production, which is not really what any of you guys who flew here to San Francisco want to hear. And then Night Capital's a pretty classic case. 30 minutes of one bad algorithm being out in production cost them $440 million, and they were bought. If you aggregate all of this, software bugs cost the economy hundreds of billions of dollars per year, right? So this is a study from 2013, but not everything is going to be high stakes, right? I don't know if anyone here has been through anything quite as devastating as the boxes over there, but it all adds up, right? Just because you don't lose $440 million in 30 minutes doesn't mean you're doing a great job. There's always room for improvement. You can always improve your processes and your focus on testing, and testing is paramount to having good quality product out there. So assuming that we've agreed, I think. Does anyone not agree that testing is important? Maybe not the right talk for you. Just kidding. But testing is important, and let's talk about some business pressures that affect testing. So get it out the door mentality, right? We live in a competitive landscape. Getting features to market is critical, and oftentimes that conflicts with spending more time on quality. And that's not a great place to be, but it is reality. And so everyone struggles to find a balance. We'll test more later. I was a dev for 5.5 years, not too long ago, and I've certainly seen this. Testing is not glamorous, right? It's a lot more fun to write the piece of shiny code that users are going to use and be able to talk about it. You don't want to, spend your Friday evening saying, "Yeah, I, wrote a bunch of unit tests today." So it's almost natural to want to kind of punt on it when push comes to shove. Anyone who's been dev can tell you that if you don't write the tests when you're checking in the code, you're probably never going to get back to writing them. That debt that adds up over time is going to show itself in a bunch of ways. New feature commitments, a little bit tied in to get it out the door mentality. When you're frantically trying to check off the list of features that product management and the company has kind of signed up for, testing is one of the things that, when you say, do I get that one more feature out, or do I say, okay, guys, go ahead and write all these unit tests that you keep talking about, right? So testing can fall through the cracks because of things like this. And finally, fast feedback. So this is maybe a little bit more of an advanced use case. If you have organizations where the automation is advanced, the continuous integration or CI cycles, they can get so long that sometimes testing starts to get moved out. If you have a 4-hour, 6-hour static analysis or code coverage block, can you afford for all your devs to wait for their feedback for 4 or 6 hours? Probably not. You might push that out. You might push that out to your nightlies or to your, pre-release builds or something like that. And that's not a great answer because those things provide value. The longer you wait, the less value you get. The longer your developer has to, developers are by far some of the most, treasured resource time that you have in any company. They're kind of the foundation on which all of our companies are built, or all software companies are built, rather. And the context switch penalty that they face when they have to go back and try and figure out what broke. I don't know if devs remember what they wrote a week ago, let alone a month ago. So having to go back and not have a fast feedback loop to understand what you're breaking or what you might be affecting can be very costly. Many of you have probably heard of Martin Fowler. He's written a lot around automation, continuous integration in general. I really like this quote. He talks about the commit build or the CI build. And that's kind of, there's a lot of different types of testing, right? So kind of the title of the talk today is speeding up your continuous integration builds with test acceleration. There's a lot of different types of testing beyond the things that you might run in CI. There might be functional tests, there might be regression testing and stuff like that that's not tenable to be in your 10-minute cycle. But for CI builds, he talks about this magic 10-minute number. That's kind of the point at which if you're getting beyond 10 minutes, I'm not going to say that if you have a 15-minute CI cycle, you're doing poorly, but I've seen places that have CI cycles of a couple hours, 3 hours, or something like that. There's a company that we worked with where they basically called their CI builds coffee time because that's what they did. The devs submitted something and then they got coffee, hung out for a while, came back, and you scale that out to a lot of developers. That's very costly. So I have a question for the people in the room. How many people here have CI cycles at 10 minutes or less? We got one kind of partially raised hand. All right, 2. All right, great. Yeah, so usually not a big percentage of the industry. So what are some of the basic groups of CI testing tools? Right, when we talk about them, we usually encounter 3 of them: unit test tools, static analysis tools, and code coverage tools. So again, focusing on CI today. I know there's a whole lot when you're talking about testing in general, but really focusing on continuous integration and the things that you want to run on a constant basis, not only in your CI builds, but also enable your developers to run them fast as well. So assuming that you do have testing, right? Whether it's static code analysis, code coverage, unit testing, what are some of the typical fixes for long test suites? One of them is manually parallelized. So, I've seen people sometimes take swags at figuring out, all right, this looks like I could probably, break this out into 5 or 6 pieces and run them in parallel against them. It's not bad to do that, but I hate the word manual. I work for an automation company, and it's just expensive to have to do things manually, and it's also not scalable. Buy faster hardware, right? That's a quick fix. It's an expensive fix, and you're not taking advantage of the hardware that you have bought. But if you're going out there to buy 64 core machines just so you can run your tests faster, your builds faster, whatever, right? You might want to take a look and see if there are things out there where you can, with the tools that you have, or with other things, you can actually speed up and make maximal use of your compute power. Accept long CI cycles. This is probably the most common one, which is, all right, what are you going to do? I've got millions of lines of code now. I've got thousands of developers. We need to run these builds. They're going to take a while, right? So that's just the way it is. I'll try and parallelize a little bit here and there. I'll try and do some optimizations, but for the most part, you come to learn to live with it, especially if it's grown organically from something that used to be fast into something that's much longer. And then, as I kind of mentioned earlier, you can cut down tests and analyses that are run during CI, move them out into other builds, and as the picture kind of obviously shows, these are a lot of Band-Aid type fixes. But pushing those out into other builds, again, right? You're paying that context switch penalty. It's also much more difficult to tease apart which commit broke something when there's 57 commits versus 3. Just the other day I was working with a customer, and one of the things they're trying to do is figure out, well, I get 50 commits between each CI build, so how do I figure out, like we're literally talking about binary search algorithm, right? Like, how do you go from one commit to figure out which is the one that broke it? That's expensive, right? And that's because CI builds tend to get long. So another poll, how many people here have experienced 2 or more of these? I saw a few nods around the room. All right, a few. Good to see some electric cloud people raising their hands too. All right, so I'm going to take a step back, and I'm going to talk about kind of the journey that you might take from, depending on your maturity, to get all the way to test acceleration. I was telling a couple of my coworkers earlier, I spent a lot of time on meme generator yesterday, so I apologize in advance. You're about to see a few. But the first step 0 really is to have tests to accelerate. I've been to a lot of places where we start talking about, we start talking about automation, start talking about test acceleration. I shouldn't say a lot, at least a couple, where people kind of light up and say, hey, we haven't been great about writing tests. Are you saying that your tools could generate tests for us? And the answer to that is obviously no, right? There's no tool out there that's going to be able to write the tests for you. If it did and they just passed, then you're not doing a good job. A well-written unit test is one where you know what's supposed to fail, you write the test fails, you fix it, you iterate on it, and then finally the unit test succeeds. That's a valuable unit test. Obviously, all the other tests that you have in your suite succeed as well. So there are people there that are allergic to testing in the first place. Some people talk about the merits of unit testing versus functional testing. I'm not really talking about that debate here today. I'm talking about tests as a whole and testing as a whole. But you have to have tests, and that's definitely the prerequisite to be able to accelerate them. So assuming you have tests, the number one place to start, I can only imagine you guys have seen this a few times so far at this summit. I have it in pretty much everything I talk about. Not just for CI and testing, but everything is automation, right? Automation is in of itself a massive acceleration tool. Automate everything that you can. Any task that you find yourself or multiple people doing multiple times is something that, as long as it can be automated, it should be automated. Another story from kind of what I do out in the field is, I talked to someone and they were like, yeah, so we have scripted builds, right? And I was like, okay, cool. Like, how are they scripted? How do you run them? And they're like, well, we kind of just walk through the script. And I was like, it took a while to get there, but we finally realized they're talking like movie script. Like there is a document that says these are the steps that you take to get your build, right? So movie script versus shell script, which is what I was thinking. So again, different levels of automation. I see some people smiling, but automation, like I said, in of itself gains you a huge amount of acceleration. Coarse-grained parallelism, right? So run more things at once, right? This is a win, no doubt, especially if it's automated, right? And not kind of the thing I talked about earlier where someone's manually splitting up test cases or test suites and then running them across a few machines. Talked to a customer a few months ago, and they have 5 licenses for HP Quality Center or Quick Test Pro or some tool like that. And basically what they do, it's a very waterfallish process for them. What they do is once the QA team gets the bits, they look at the test suites and they kind of eyeball the 5 ways to parallelize them, and then they go and run those 5 mini suites on 5 machines that have licenses for them. That's better, but it's not, that shouldn't be the end goal. You should be having it so that parallelization, that splitting up is figured out automatically. And it's not difficult to do this with automation tools, but I'm going to tie this back to what I said earlier. You have to invest in automation. You have to invest in your software delivery lifecycle to make it better. It's not something that happens magically. Investing in something like coarse-grained parallelism with the tools that you might have is very valuable. And then we get to fine-grained parallelism, right? So even more stuff at once. What I talk about when I say fine-grained parallelism, and I'm going to talk about our product in a second. A lot of what I've talked about so far is kind of product agnostic. Fine-grained parallelism is really breaking things down to the smallest possible unit that you can, right? We talked about coarse-grained parallelism, but getting to the even finer grain and being able to run all these itty-bitty things on as many compute nodes as you need. Compute is cheap today compared to developer time, right? You can, it doesn't cost that much to spin up a few VMs, or if you use the cloud, for example, it doesn't cost a lot to spin up a few EC2 boxes for the duration of your test suite, and then spin them back down at the end of it. The cost is the upfront cost of getting that in place, but after that, you're going to gain serious benefit from a much faster CI cycle. And this can sometimes take creativity, but it's time well spent. A couple of the use cases that I'll walk through, I've spent time trying to figure out, how do I run just one test? How do I list out the total number of test cases? That's not always easy. Some test harnesses make it easier for you. Some test harnesses are more difficult, but it is time well spent either way. And it's especially because it's a one-time cost you spend up front. So quick show of hands. How many of you guys have heard of Electric Accelerator? All right. Good to see our chief architect raising his hand. How many of you know it as a build or compile acceleration tool? All right, great. So we wrote Accelerator. Eric Melsky, by the way, he's our chief architect, and he's been with the company since 2002. And he and other folks, they wrote Accelerator back in 2002, and it's a pretty general purpose distribution utility. Now, we sold it for years as a build and compile, C++ build compile acceleration tool. But the core technology is just completely agnostic to what you're running. It just, if you have these small units of work that you want to parallelize across your CPUs in your cluster, you can do that with Accelerator. So that's kind of, just as recently as yesterday, I was talking to someone and he's like, hey, why are you talking about Accelerator? That's a compile acceleration tool. I was like, here we go, unwind that and talk about it. But one key point with Accelerator, there's a lot of tools out there. And again, like I said, with your current automation tools, you can split things up at a pretty coarse grain. Accelerator, the reason it's fine-grained is because it runs things on essentially CPUs, right? So if you have 3 or 4 boxes, that's not 3 or 4 tests that you're running in parallel. If they're all 4-core boxes, that's 12 or 16 tests that you're running in parallel. And that really enables you to extend your compute infrastructure and use it kind of to the maximal amount. So, a couple of quick points about it. Massive parallelization distribution, we've been doing this a long time. It automatically detects dependencies. That's a little bit less important when it comes to testing because tests shouldn't be dependent on each other. You should be able to run any test in any order and they should be able to succeed. Now, one of the things that you'll find as you parallelize things is that these tests may not succeed because there are dependencies, and that's a learning experience, but then developers get used to that. But it has automatic dependency detection by watching the file system and watching the registry and seeing if there's any kind of conflicts where this test wrote a file that the other test needs or something like that. So it finds those things for you. It has a lot of visualization. I'll kind of save that for the quick demo I'm going to do later. And a key thing to, not Accelerator, but test acceleration in general, is you want to make efficient use of the resources that you're paying for, that you've already paid for, that you're going to pay for, or whatever you have that's accessible to you. One thing that a lot of you may not know is we do have a free version of Accelerator. Anyone who's interested, feel free to. It's on the Electric Cloud downloads page. It's called Huddle. It's kind of purpose-built for smaller teams. Say you have or development teams really. Say you have 15, 20 developers that all work. They all have these. I have a 60, an 8-core, 16-core machine. A lot of RAM on them. They're not always using them all the time. So why not take advantage of that compute power? And so what the teams can do is they can create this huddle where they're all kind of subscribed in, and if one person runs a build, it'll parallelize out on the others. So it uses Accelerator as its core technology, and everything you see today translates over to Huddle. But it's also a way for everyone over here to quickly get your hands on it and test it out if you want to attack that fine-grained parallelism. All right, so a couple of use cases. Checking my time real quick. All right, a couple of use cases. And as I promised earlier, I'll talk about a couple of use cases that I've personally had in my work thus far the last couple of years. I showed the Martin Fowler slide earlier that talks about that 10-minute magic number. I encountered a company where they had a new product that they built. They wanted it to be, it was a big company. They wanted it to, all their software best practices encapsulated in the way they built that product. And so they had every type of testing imaginable. They had all the code reviews and all the right source control things. They wanted it to be kind of the poster child. But the one thing they found as that product was growing, that their CI builds were getting longer. And their CI builds were up to 20, 25 minutes or so, which isn't untenable, but again, this was supposed to be their poster child for development. And so they wanted to establish best practices with it and get into that magic 10-minute number. I went there, they had the Jez Humble book, they had they had all these books on there. They were the academics, these guys around how to make their software delivery processes the best. And this was one of the key things that they were chasing. They're also sticklers for test-driven development, right? They know that their suites are going to grow over time. They knew it was only going to get more as the years progressed, and they wanted to make sure that whatever they put in place was scalable. The tools they were using in this particular, is a Windows-based product. They use Boost for their unit tests, Microsoft Visual Studio Code coverage, and Bullseye for static analysis. And the time to run the tests and coverage when we were there, like I said, it wasn't huge. It was 7 minutes and 30 seconds. After just adding 2 machines into their cluster, they got down to 3 minutes. But because we spent the time figuring out how to run each test case individually, which is not something that Boost makes easy, we were able to get down to a best case of 40 seconds. And the acceleration X factor, if that helps, 2.5x with 2 hosts, but it went up to about 12x with more hosts added to the cluster. And the key for them is that 39 seconds. That's what they were focused on. They wanted the fast feedback. And 39 seconds is essentially, because tests don't depend on each other, 39 seconds is the length of the longest test suite to run. Now you do pay a little bit of overhead when you parallelize because you're not, you're starting up your test framework more times. But at some, that point of kind of, diminishing pain of starting that up is pretty soon. So once you start to parallelize out, you'll see that that penalty, it doesn't actually cost that much at scale. Another use case, and one that I'm actually going to be showing in a demo, is browser tests were not previously run during CI because they take too long. I'm sure that a lot of you guys have heard of Selenium. So Selenium is the tool that they were using. Selenium comes in 100 different kind of, missing a word, but there's 100 different ways you can run Selenium. And in this particular case, the time to run the sample test suite that we put together to prove out the acceleration was about 30 minutes to run the 100 tests. And after, I'll build this out, but after just having 2 machines with 4 cores each, so 8 tests running in parallel and them all kind of neatly lining up one after the other, it was able to go down to under 4 minutes with the best case of 27 seconds. So you're not going to have machines, you're not going to have 100 cores available because unless you do, that's awesome, right? I'd love to have that problem. But you're going to find a point where you're going to say, all right, that's the size of the cluster that gives me the best bang for my buck, and so I'm going to parallelize it to that amount. But being able to do it automatically and being able to have that acceleration automatic and scalable is very powerful. So I'm going to move to a quick demo. Shouldn't be more than 10 minutes. And this is actually of kind of a lab that we set up at Electric Cloud for testing Selenium. So this is a sample web application. This is just something that the Selenium test suite that we put together, it hits it clicks around a little bit, and then I have a bunch of like random time sleeps as well, just to kind of simulate a regular Selenium test environment. And move over to my shell over here. So this is it. Oh, great. All right, give me 1 second. That's what you need for live demos. All right, I think I'm back. So this is what the test suite looks like. Like I said, right, there's 100 different ways you can run Selenium. This just happens to be HTML tests that are going to run against Firefox. People have them running against different browsers. You have them written in different languages. There's a lot of different wrappers, so you can write them in kind of like a human readable language. These are fairly basic. They're HTML-based Selenium tests. It's not the style of Selenium test isn't really the point of the conversation, though. It's more about how do you go about accelerating something. So, but before we do that, I want to show you how do you actually run one, or how do you run Selenium, without accelerating it. And this is the standard command, right? It's a Java command. In this case, we're using this standalone jar or a standalone Selenium server. We're talking to that website that I just picked up, and we run the suite, and it pops out results to an HTML file. Fairly straightforward, kind of almost Selenium 101. This suite, like I said, to run all 100 takes about 30 minutes. So how do you accelerate, right? And so how do you split this up? We're talking about fine grain, right? You could do it at a coarser grain. Maybe you have a lot of suites and you just want to run suites on different machines at a time. In this particular case, I want to run each test on a different, at one time. So step number 1 is enumerate all the tests. Now, enumerating this test, the test is super simple. I just do ls star HTML and I get the list of tests. It's not always that easy. Some test frameworks, I talked about the boost case. We actually had to write a script that went through the file system and found test modules and then the suites within those and then the test cases within those. And it was work, right? It was like, it was a good couple days of figuring out how to enumerate all the tests. But that's the first step, right? You have to be able to enumerate all the tests. The second step is you need to be able to know how to run each test. How do you run just one test? Again, a lot of test frameworks don't make that easy. Some of them is just as simple as an option on the command line. Others, it's not. In the case of Selenium, actually, I would have had to create an entirely separate suite for each test, and that didn't seem all that usable. So I Googled a bunch and found a tool called Selenium. For anyone who's here that knows Selenium, you might have heard of it. It's pretty much Selenium.runner, and then test1.html. That's how you run one test, right? So you just call Selenium, you pass the test to it. I'm sure there's a lot more environment variables and stuff like that that you might use in a complex use case, but at a very simple use case, it's just going to run one test at a time. And that's what we need. We need to break them up into pieces. We need to know how to run each one. And now we can put them together. We can glue them together and run them at scale across a cluster. So once this test completes, and it shouldn't take that long, each of these tests takes 20, 30 seconds. What I'll do now is I'll kind of show you what our team has put together is this test acceleration markup language. And essentially it's a YAML, and it's a very simple way to say, what are the partitions, right? And again, right, I'm just doing ls over here of test_star.html, and how do you run each partition, right? Once you can find those two things, then you can parallelize. I also created a subset over here. You can see over here, I just kind of pipe it to 10 so I can run a smaller test over here, but that's pretty much it. And then we run etest, which is kind of our wrapper to digest this and parallelize it out across a cluster. And I'll run the subset first. And this will take around about a minute to run those 10 tests. And those 10 tests took about 3-4 minutes to run in serial, which is great, 4 minutes to 1. You saw the numbers earlier. When you start to scale that out across more, it becomes much better. So I'll show you a little bit about what this looks like, what's actually going on in the background. And I mentioned earlier these agents, right? Or these hosts. What are you parallelizing on? We have 2 hosts in our cluster, 2 machines. And usually that means that you can run 2 tests at one time or 2 suites at one time. Because the nature of Accelerator, for anyone here who's familiar with it, we actually create completely isolated silos on each CPU core. And so these 4 core machines essentially give you a cluster of 8 parallelism, or 8 things to run in parallel. In this case, tests. We're running 8 tests at one time. Each of the agents right now is busy running a test. If I refresh this, I'll probably see that some of these tests are starting to complete. The agents start to free up. There's a graphical way to view this and all that. But what I really want to show is kind of the nature of the product is just parallelize stuff, right? And parallelize at a very fine grain across CPU cores. So it's nicely packaged in a way that you really take advantage of the compute power that you have. You can see over here it's complete. It took about 1 minute and 11 seconds. I'll also run this for everything, and I'm not going to make you sit here for 7 minutes watching this run. But in the meantime, what I'll do is I'll kind of show you what this looks like. And if I scale this out to 100 Selenium tests, I apologize. I know it's probably not that hard to see for you guys in the back. But really the key over here is across those 8 agents, right? What does each test look like? There's no dependencies between them, so it kind of like it fits in very nicely. And that's the type of parallelism. This is the kind of visualization, no matter what you're parallelizing or how you're doing it, this type of visualization of your process is extremely powerful, right? If you're just talking at a very high level of the way that you accelerate or the way that you run your builds and you pull that out, what's the long pull? You always have to go after the long pull. You always have to make the long pull shorter. That's the key to acceleration. And whether the product does it automatically like Accelerator or something else, you always want to make sure that that's your focus. And the key thing, and again, right, as an SE, solutions engineer, what I do in the field a lot is I spend some time on the whiteboard with the customers talking about what is your software delivery process. And on more occasions than one, the customer will at the end go up and take a picture of what we whiteboarded because they're like, I had no idea, right? This is super valuable. There's a lot of value in just spending time discovering what your software delivery process looks like. This is what this is kind of what the Selenium tests will look like, parallelized. We talked about the boost tests earlier, right? And I'll kind of go down the progression. We started at a very coarse grain with a module level parallelization, and we quickly found there's one module that takes all the time, right? So we know that we have to break it down a little bit further or make that one shorter. And so we then went down to the suite level, and that was better, but we still saw that there were some suites that took a lot of time, right? So we finally spent even more time. We broke it down to the actual individual test case level. And that's this one over here. And now I don't know what you can see in the back, but up front over here, you can see that you can almost not read anything. They're very, very small boxes that have scaled out very well. And this was on just 5 individual workers. But if you kind of build this out across more, we have this simulator technology, which will actually scale this out. What would it look like if you had a bigger cluster? What would it look like if you had a smaller cluster? Where do you find the point at which you're interested? I'd probably stop at about 20 and say, all right, I'm good with, a minute and 42 seconds. That's an awesome improvement. But it can go all the way down to however long your longest test is. So I don't think this is completed yet. I think I talk faster up here than I do when I rehearse. But we'll go back to the PowerPoint. So how does parallelizing tests help, right? Kind of wrapping up all the things that I talked about in the beginning. Shorter CI cycles without sacrificing, right? Don't just cut stuff out. Test avoidance and stuff like that is also incredibly powerful, right? That's another technique that you can take to make sure that when someone's commit comes in, you know exactly what pieces of code need to be built and tested. That's difficult, but possible. But at the end of the day, you want to make sure you're not sacrificing something that will affect the quality of your end product. You want to maintain comprehensive testing. Comprehensive testing paramount to having great quality in your product. You want to scale no matter how large your code base grows, right? Which oftentimes involves, it's usually a reactive thing. Your CI cycles have already gotten so long that you need to cut them down. But if you're starting something from greenfield, think about the scale over time. You want to minimize your new hardware investment while maximizing your current hardware investment. So like I did mention earlier that compute power is cheap, but it's not free. And if you already have a bunch of servers lying around under desks and stuff like that, developer machines to put together into a huddle, take advantage of that and run stuff on it. Continue to use existing tools, right? So different types of test tools have different purposes, and always make sure that you're watching the landscape and making sure that you're using the best tools. But you're not going to use Selenium to test out your embedded your embedded hardware product. And then learn what tests take the longest and if there's any dependencies between them. Like I said before, you have to go after the longest pole in the tent. That's the best way to get acceleration. And maybe another way to look at the journey is if your commit through production cycle takes weeks or months or whatever it may be, right? Maybe days, right? You can always optimize. Automation brings it down a ton, right? Just having these things run automatically every time someone commits, or having people run pre-commit builds or something like that, brings it down from weeks to days. And then accelerating them and really focusing on performance of your software delivery lifecycle can bring that down much further. So focus on speeding things up, bringing them down, and this journey is one it doesn't ever end. It's always evolving. You guys, you're all here for DevOps Summit, and you know that DevOps never ends either. It's more of a lifestyle. Bringing it back to Martin Fowler. If it hurts, do it more frequently and bring the pain forward. That's true probably for a lot of things, but certainly when it comes to testing your software, right? I don't know what the story was behind healthcare.gov. I don't think a lot of us want to know what the story was there. But those types of situations are what we really want to avoid, and we do that by making sure that we get the test results, we get our quality metrics, and we do that early and often. So I think that's done a little early. So that's all I have for today. Go to our downloads page, like I said, to check out Huddle if you're interested in that. Feel free to grab any of us over here. Like I said, Eric and some of the other engineers from our team are here as well. If you have any questions, I'm in sales now, so I can't really answer the hard ones. I started tweeting yesterday in earnest, so I put my Twitter on there. But anyway, any questions? Yep.
Through your experience, who does the new creation of the Selenium scripts at check-in time, right? Because what I'm running into problems with is the developers are saying, hey, I don't have time to do it, right? So if you went continuous integration, you check in the code, but there's no scripts to actually test that particular new functionality they're checking in. How do you? What do you do? Do you have the developers do that, or do you have the testers do that, or who does that?
So I'll repeat the question, and it's a great question, which is who writes the Selenium tests, right? Who writes the tests in general, right? I'll take it one step back. If the developers say they don't have time, they got to move on to their next Jira, and they don't have time to write them. Do the testers have to write them? I think that tests are, so first off, it depends on the company, right? It depends on the size of the company, the dynamics of the company, the culture of the company. I think that for a situation where a developer writes a piece of code and then doesn't, just puts his hands up and say someone else go test that, I don't think that's great. I think the person that writes the code understands the code and the functionality very well. So in the spirit of DevOps, I think it's important for QE and engineering to work closely together if they are kind of separate functions. Unit testing generally is something that a lot of developers will do themselves, and certainly at Electric Cloud we enforce developers writing their own unit tests. All right, there was another question. I think any other questions? All right.
How does the Selenium thing compare to Selenium Grid?
How does the Selenium thing compare to Selenium Grid? So those two are actually separate altogether. So Selenium just runs one test. Selenium Grid actually parallelizes by running one test on one host at a time. And I think it can maybe parallelize a little bit more than that. So I think maybe the question is more Selenium Grid versus what I showed you with Accelerator. With Accelerator, I haven't run Selenium Grid myself. I've kind of heard anecdotally. Last place I give a similar talk was at a testing conference up in Canada, and a lot of people said, from reliability and consistency standpoint, Selenium Grid is mixed reviews. I don't know, I haven't used it myself, but it also does it parallelizes at a host level for the most part, whereas Accelerator is really doing it at a core level. So you get a finer grain, you get more out of your CPUs. I don't have a really technical answer there for you, unfortunately.
Over at Electric Cloud, what percentage of unit testing do you guys do that? Are you using any tools for unit testing?
Okay, great question. So a question was, at Electric Cloud, what percentage of our code is tested?
Yeah, unit testing.
Is unit tested? And do we use tools for unit testing? I actually, if you have an answer, he's closer to it. But we've always had a strong culture of test automation and unit testing everything. So we have a pretty high coverage rate, and some of our tools, depending on the tools, if it's a C++ tool, like I said earlier, right? Like different tools have different purposes. So we'll use JUnit for our Java code, and we'll use Selenium for functional testing, and we'll use CPP unit for C++ code. So it really depends on what type of code we're testing. We kind of find the technologies that match that best.
Those are tools, but what percentage of unit testing? Do you have that metric? Do you track it?
What percentage of? You mean like what percentage of like our code coverage, basically? I don't have it off the top of my head.
We don't directly measure that. As Tanay said, our engineering culture has always strongly emphasized unit testing, and it's a requirement, particularly when we're doing bug fixing. You're not allowed to check in the fix without a corresponding regression test to match it. And when we're doing the as Tanay said, we have always had a strong unit testing culture at Electric Cloud in the engineering department. We don't directly measure the code coverage there, but we do have a requirement that you have to have a regression test that goes in with any bug fix that you check in, and as you're writing new code, we have a sort of formulaic way that we go about doing the test development. The term we use is that we make our tests isomorphic to the code. So if you hold up the test suite alongside the code, you should be able to read line by line as you go through the code and find a corresponding test for every line in the code. So I would estimate, honestly, our code coverage is probably higher than 80%, but I don't actually measure it directly.
But it's still code review, right? Do you call it as a unit testing? Or you just explained it to me, it's more of a peer-to-peer code review?
No, I'm sorry, you've misunderstood. So I write tests, and the way I decide what tests to write and how many tests to write is by following along in the code. So it's very much Whitebox testing, as you would expect for unit tests. The end result, the artifact that's produced by that, is a test suite that is run on every continuous integration build. So On our continuous integration builds, I can tell you we have close to 10,000 tests that run on every CI build, and we have about, let's say, 200,000 lines of code. So, as I said, I don't have the number directly.
Yeah.
But I would estimate in excess of 80% code coverage.
And I think part of what Eric's kind of touching on as well is there is a cultural aspect as well to testing, right? So it's always been ingrained in our culture from the very beginning, from the founders of the company, Eric included. So again, right, like not making testing an afterthought is kind of key to that success.
I can answer a little bit on the flow side. We started to use Clover, Atlassian Clover, and we also tried to use Jacoco, the Gradle. So between those, I also don't know just offhand what the rates are, but I know in our one interesting anecdote after we started doing this was our managers would start reading so we would have stories in Jira's for a topic, and the managers would sort of see the code getting checked in, and they would be able to correlate that with the tests and the test coverage, and that would inform, like every day or every week, the managers and the QE managers would get together and say, okay, out of the 10 people that I have for testing, I want a higher degree or emphasis on this portion of the code or this feature, because I'm able to see that the code coverage is a bit lower lower than others. So that's kind of, but I don't know the rates.
I can shout. I had a two-part question. So first thing is, we saw some use cases like Selenium and JUnit. Is the Accelerator a tool agnostic? Like, can I parallelize UFT or any of the other testing tools?
Yes, it can. Yeah, so it's completely agnostic to the type of tool, as long as you compartmentalize and you can run each thing individually. You can run whatever you want.
Okay. On the similar lines, I mean, Selenium would be good enough, but then we use certain cloud providers like Perfecto or Ctest or some of the cloud providers. Does this have the ability to even understand how that sequencing needs to happen at the device level as well in order to do the parallel testing, or?
I'm not sure that so when you talk about cloud providers, are you talking about, but you also mentioned device testing. Can you kind of elaborate?
So device providers means like Perfecto or Ctest is, instead of having your own device, you host the device on a cloud.
Okay, gotcha.
So that's why I was just wondering, does the Accelerator help in that case as well?
So Accelerator, when you're talking about splitting stuff up and running it in general, I think, but certainly with Accelerator, we essentially just, you give us the commands to run and we'll run them. So if the device, I'm not familiar with what you're talking about, but if that framework supports the ability to run multiple tests at one time, right? And it's just a matter of execution. Accelerator is kind of a server agent model. So, it's just kind of a client agent model. So the client will just ask for agents and run stuff on them as they become available. So if the agent can support, or if the host itself can support multiple tests running, then part of the tool agnosticism is that it depends on whether that test can run in kind of a multi-process format, and if it can, then you can use Accelerator with it. Maybe I can grab you afterwards. Thanks. Any other question?
Is it pretty much one agent per machine, so to speak? And you said you had a machine that's got 4 cores.
Yeah.
So you can run 4 processes, but it's still one agent for that one machine?
It's actually 4 separate agent executors. Yeah, and they all have they're isolated from each other, so they're not seeing what each other are doing. So you could have multiple things. You could have multiple test suites running on the same host using different agents, but they're all isolated. All right. Any other questions? All right. Well, thank you. Let me know if you have any more advanced questions. Thank you.